Hello friends, today we are going to see one of the session which is, if you consider a banking exams like clerk exam, it might not be very important because there won't be any question, but it has application into probability, and probability can have multiple questions. Definitely there will be one question in pre-exams, but in main exams there can be a complete set about the probability. And to understand the probability, it becomes very important that you understand permutation and combination. And plus, the exam that we are targeting, RBI Grade B, now it is changing the patterns and type of the questions. Now it is shifting more towards the other management entrance exams like CAT, and it is breaking the old shackles, and it is deviating itself from the typical questions that the banking exams ask. And that is why it can happen that they ask 2-3 questions straight away from permutation combination with the core questions of permutation combination that the other banking exams never ask. That is why you have to understand permutation and combination. When you talk about this topic, first of all, this is the itself a permutation combination and probability itself is a branch of the mathematics. So if you have to study it in depth, you have to then study it as a separate subject. But we study only as much we require for the exam. Because even if you consider one single question, like 5 boys and 5 girls are sitting, you can make like 100 of different variations within that question. 2 boys sit together, 2 boys don't sit together, 1 girl and 1 boy is always together, and 1 girl and 1 boy is never together, or 5 boys together, 5 girls together. So many combinations can be made only in case of 5 boys and 5 girls to be seated in a row. So that is why you don't have to learn everything. You just have to learn the basics that they ask in the exams, and you can just move on. Because as I said, it is not going to be very useful in other banking exams. It is just about the RBI Grade B and challenging exams like SBIPO. So let us start with the very basics of permutation and combination that we call as the fundamental principle of counting. Now, why did this subject introduced, or what is the importance of permutation combination is to measure the number of cases or to count certain things which otherwise manually difficult to count. So we have to form some system to count stuff. So if I ask you, how many squares are there on a chessboard? So consider this chessboard here. So this is the chessboard. We are to answer how many squares are there on a chessboard. So a student who is fresher definitely thinks there are 64 squares because we play chess. At least in childhood, we have played the chess. We know what chess board is. So usually the answer I get is 64. But no, 64 is of course not the answer, because when we say 64, we are only counting the small ones, this size. But this is not the only size. We can have the bigger size squares as well. This is also square, 2 by 2 square. This also is a square. 3 by 3 will also be a square. 4 by 4 unit also square. 5 by. So there are different sizes square that all you have to count when the question is how many squares are there. So of course you try to count manually, it is going to be impossible. Impossible in the sense because there will always be chances of you missing some squares. There are lots of squares. So that means you have to form some system so that you don't miss anything. The system that we are going to form here is, we are going to go size by size. So size, if I say 1 by 1 size square, they are 64 because you know such 8 squares are there and such 8 squares are there. In every row there are 8 square. So 8 by 8 or 8 square, there are going to be 64 number of squares. If you talk about the size 1 by 1. Now size 2 by 2, when you say like this size here, the first square ends here. The second square, it starts from here and it ends here. The third square will end here. Starting from here, end will here. The fourth starts from here, end here. Fifth, sixth, and seventh. So that means 7 squares per row, and there will be such 7 rows. So that's why 2 by 2 size square will be 7 square, that is 49. Now 3 by 3 size square, if you try to measure, the first square will end here, 3 by 3. So this 3 by 3. The first square ends here, second ends here, third, fourth, fifth, and sixth. So there will be such 6 squares by 6 squares, 6 by 6, 6 square. There will be such 36 squares. So now you can observe the pattern. As you are growing this number by 1, this number is getting reduced by 1. So 4 by 4 size square are going to be 5 square, that is 25. 5 by 5 squares, size squares are going to be then 4 square, that is 16. 6 by 6 sized, 3 square, that is 9. 7 by 7 sized, 2 square, that is 4. And 8 by 8 sized, 1 square, that is 1. So 8 by 8 is this entire big square. That is definitely going to be the one. So all you have to do is now add these all. So you must be knowing sum of squares of n natural number is given as n into n plus 1 into 2n plus 1 upon 6. Basically, if you want the sum of 1 square plus 2 square up to 8 square, so you just have to put the value of n as 8 here. Put n is equal to 8 here and we'll get our answer. The answer will come up to be 204. So if you understood this very well, if you still don't, watch it again and then you will understand. And if still doesn't, then you can just remember this formula. This is the formula for number of squares in these type of figures. So all you have to do is put value of n as the number of squares on one side. So here on one side there are 8 square. So put the value of n is equal to 8 in this formula and you'll get your answer. I hope you got this. Now let's see what basic principle or fundamental principle of counting is. So as I said, PNC is all about counting the number of cases. So to counting, whatever the system we adopt is called as the fundamental principle of counting. For example, if I say there are 3 students A, B, C, and there are 3 chairs, 1, 2, 3. How many ways you can make these 3 students sit on these 3 chairs? How many different ways they can sit here? Different ways means A, B, C. This is one of the way. Now A is here against whose? C and B are here. Then if B sits here, AC will be the case. And if B is here, CA will be another case. If C is here, AB. And if C is here, BA. So thus we have ensured that we are not missing any case because we have made sure that at this position, everybody comes. And when somebody comes at this position, we have made sure that both these other two are rotated on these 2 chairs. And thus we have covered all the possible cases. And that is why there are total 6 cases or 6 ways the 3 people can sit on these 3 chairs. So how these 6 arrive? See, there are 3 chairs. On first chair, we have 3 choices. You can make either A seat, B seat, or C seat here. So we have total 3 choices. Let's say we made A seat on this place. So against A here, there will be 2 choices. Either B or C can sit here now. So either B or C can sit here. That means we have 2 choices. If we say C sits here, now we have only one single choice here, that B only can be seated here. And if B sits here, there is only one choice. So all the 3 choices here, against those we have 2 choices here, and against those we have 1 choice here. So 3 into 2 into 1, we write it as 3 factorial. And the value of which is 6. So if there are 5 students, the answer is going to be 5 into 4 into 3 into 2 into 1. Exactly like this. And the answer will be 5 factorial. That is 120. So factorial itself means the product of first n natural number. For example, if I ask you what is n factorial, n factorial will be n into n minus 1 into n minus 2 up to 1. Except 0. 0 factorial is 1. You have to remember this. 0 factorial is 1. Okay, based on this, let us try to answer another question now. How many 3-digit numbers are there? So if you are asked how many 3-digit numbers are there, so first of all, you can do it manually. Like first number is 100, first 3-digit number is 100, and the last 3-digit number is 999. So if you are to count how many numbers are there between 100 and 999, including both. So if you have to include both, all you have to do is take the difference and add 1 to it. Add 1 to it. So difference is 899 plus 1, that is 900. So there will be 900 numbers between 100 to 999, including both. If you have to include both, you have to add 1. But where is the PNC here? You have to have the PNC method as well. So PNC method says if you have to form 3-digit numbers, you have to have 3 places for you. On the first place, how many choices we have? We have total 0 to 9, that is 10 digits. So can all 10 digits appear here? No. 0 can't appear here because if you put 0 here, that won't be a 3-digit number. So for it to be a 3-digit number, 0 can't appear here. You have only 9 choices here from 1 to 9. So say you put 3 here. You put 3 here. So how many choices we have at this place? Can you put 3 here again? Yes. For example, 336 is a 3-digit number. 3 here also, 3 here also. So there is a difference between people sitting on chair and numbers putting on the place because same number can appear on 2 places as well. 3 here, 3 here. But a same person cannot sit on 2 chairs. A is sitting on this chair also and this chair also, not possible. So yes, it is a game of choices. Every time you have to think about choices, but smartly. Numbers, they can appear on multiple unless provided so. Unless given that repetition is not allowed, you can obviously say in numbers there is repetition. So that means we have all 10 choices here because now 0 also can appear. 3 also, 0 also. So all numbers, all digits from 0 to 9, all 10 digits are welcomed here. Say you put 2 here. So here again we have all 10 choices. Say you put 1 here. So 321 number is the what you have formed here. Out of total 9 against 10 against 10, that means 9 into 10 into 10, 900 choices. So we have total 900 choices. The numbers that I have written in the box like this is just example. When you follow like this, by putting 3, what can you put on the next place? Then you understand it very well. This is just for the understanding. It is not that you have to put 3 there. There are 9 choices. Out of 9, you can put any. And against that number, how many you can put on the second place? That is what we are seeing. So this is about 3-digit number, but for the record, you can just say if you want 1-digit natural number, we are talking about natural. 0 is not a natural number. So 1-digit natural number will be 9. 1, 2, 3, 4 up to 9. 2-digit natural numbers are 90. 10, 11 up to 99. There are 90 numbers. 3-digit, there are, as we just saw, 900. 4-digit, they are going to be 9,000. And 110 will keep increasing as we increase 110. So this is what you must know before even going for the questions. Sometimes because you won't even need the knowledge of PNC if you know this thing already. I hope you understood this. Let's see a different type now. How many 5-digit numbers have all different digits? So now what we have is 1, 2, 3, 4, 5. 5 digits, but this time repetition is not allowed because it says so. They have to have all different digits. You cannot say now that a number is 2, 3, 4, 2, 1. This is not allowed because 2 is appearing twice. So once 2 appeared somewhere, it cannot appear again. This is what you have to keep in mind. So here on the first place, again we have all the 9 choices because total we have 10 choices, out of which you cannot put 0 here. So we have 9 choices. Say I put 3 here. So can I put 3 here again? No. Can I put 0 here? Yes. So out of our list of 0 to 9, 3 goes, but 0 comes. That means again we have 9 choices. Let's say I put 1 here. So now here, can I put 1? No. Can I put 3? No. That means I have now only 8 choices for the next place. Say I put 2 here. So can I put 2 here? No. 1 here? No. 3 here? No. So one choice will get reduced, 7. And if I put, let's say, 4 here, here I'll have only 6 choices. So one choice will keep get reducing. So 9 into 9 into 8 into 7 into 6. Those many 5-digit number will have all different digits. If you want, you can solve this or leave it there. Okay, it is just about the calculation part. Let's see next one. How many different words can be formed using the word folder? So now you know folder has all the different letters FOLDER. So how many different words can be formed? First of all, the words don't have to be meaningful. So if it is a question asked in quantitative aptitude, you don't have to worry about meaningful words. You just are asked how many different combinations of are made of FOLDER. That means we have 6 places. On the first places, we have 6 choices. You can put either F or O or L, L, D, R. That means 6 choices. Say you put L here. Can you put L here again? No, because you have to use all 6 to form 6 letters. Any letter can't be missed. So every letter should appear only once. So you can't put L here. Now you have 5 choices. Then you will have 4 choices, then 3 choices, then 2 choices, then 1. And that is how we have total 6 factorial different combinations of the word folder. 6 factorial is 720. Different words can be formed using the word folder. I hope you got this. So basically, when I say how many different words can be formed, what I'm doing here is I'm arranging those. F goes here, L goes here, LOFDER is one of the. So basically, you are, look at my fingers, you are basically arranging those. How many different ways you can arrange? For example, in the first question, we saw ABC to be seated on chair number 1, 2, 3. So how many different arrangements you are doing? ABC, ACB, BAC, such a way we were doing different arrangements of ABC. So you can use either the word arrangements or how many ways you can mix it these 3 people. Both will mean the same. Right? Let's see one more question like this. How many different ways 5 persons A, B, C, D, and E can sit in? So you know now, if you have to make 5 people sit in a row, on the first place, you will have all 5 choices out of A, B, C, D, E. So if say B sits here, now you'll have only 4 choices. Now 3, then 2, then 1. So one choice will keep get reducing. And that is how we'll have 5 factorial means 120 number of ways. Let's see one more. How many different ways can 5 persons A, B, C, D, E sit on a circular table? Now this time, you need to understand circular arrangement is different than the linear arrangement. Let me give a quick example. Let's say on a this is the merry-go-round. And on a merry-go-round, there are 5 people A, B, C, D, E are sitting. So A, B, C, D, and E are sitting. And if you give a little torque to this, so now what happens is A goes here, B, C, D, E. So linear arrangement wise, if you start writing from any particular position, for example, from here, so you will be writing A, E, D, C, B. Linear arrangement wise, if you start writing like this, you will be writing A, E, D, C, B. And if you start from writing from A here again, sorry, from this position, you will be writing E, D, C, B, A. So this arrangement will be different than this arrangement if you think it as a linear arrangement. But circular arrangement wise, these two are the exactly same arrangement because they are already seated on the merry-go-round. All you have done is given a torque. So positions are not changed. This is not a different way than this way, right? So circular position wise, it is the same thing, but linear arrangement wise, it might be a different thing. So all you have to think is circular arrangement wise, that you have to keep one person fixed. For example, if there are 5 people total, you have to consider A is fixed. With respect to A, you have to think. So if A is fixed on one position and he is a part of a circle now, so for him, the remaining 4 are, with respect to him, the remaining 4 are going to be form a line. Because if A is fixed here, the circle is broken, the remaining 4 are to be seated on these 4 positions. So it's like a line for a person A. Okay. So if A is fixed, the remaining 4 can be seated on these 4 positions with 4 factorial ways. Because it is a line now. It's like a line now. There are 4 places in a line with respect to A if A is watching. So there are total 4 factorial ways with which the 4 people can be seated on these 4 chairs with respect to A. And hence, circular table, if you have to make sit 5 people, there will be total 4 factorial number of ways. So what you do basically is you fixed one person, and if one person is fixed, any person is fixed, with respect to him, the remaining people, they form a line. And line means 4 factorial, 4 people are there. 4 people can be arranged in a line with 4 factorial ways. So that means if n people are there in a circular arrangement, there will be n minus 1 factorial number of ways. Linear wise, there were n factorial ways, but circular arrangement wise, there will be n minus factorial number of ways. So if you understood this very well, if you don't, you can just remember this, because again, we're targeting exam, or we are looking for a field where these things, the knowledge, in-depth knowledge of these particular topics, it doesn't matter actually. What matters is, do you know how to tackle the certain type of questions? Only that is what matters. So that is why, if you like this topic, of course, you can go as you wish. But I'm talking as a experienced person that you don't require. Just stick with the typical questions and the way to solve those, especially these topics, because these topics don't have impact any other topic as well. If you think about ratio, average, percentage, they have impact on other topics. If you understand ratio very well, it is going to be useful in SICI, profit and loss. But if you understand how much ever you understand the PNC very well, it is not going to put any good impact on the other topics. That is why stick with the typical questions and the ways to tackle those, and that should be sufficient. Let's see one different type. Okay, now we are going to see what do you mean by permutation and what do you mean by combination. So far, we have just seen the fundamental principle of counting. So let us start with the permutation. Consider that there is a call center and there are 2 callers required. And the applications received were 3 from ABC, out of which you have to select 2 callers. Select 2. So how many ways you can select 2 callers out of the 3 callers? You can either select A and B, or you can select A and C, or you can select B and C. So how many ways you can select? There will be 3 ways. Will the selection of A be different than B and no? You are selecting A and B, or you are selecting B and A, it's the same thing. That means there will be only 3 ways. So in terms of permutation and combination, we write this situation like this. If you have to select 2 people out of 3 people, so you write it 3 3C2. Okay, C for combination. So we write it as 3C2 as long as we are just selecting. So this is called as the combination. But what permutation is, if along with selection, if you have to provide them cabin as well, that means there are 3 people out of which you are selecting 2, and you have to provide them with the cabins. This is the cabin number 1, this is the cabin number 2. So now there will be how many ways? If you select say AB, then A here, B here will be different than B here, A here. If you select AC, then A here, C here will be different than C here, A here. And similarly, BC and CB will be different. So now there are total 6 ways. This is called as the permutation. This is called as the permutation. So permutation means what? Selection and arrangement. As long as you just had to select, you write 3C2. But if you have to select and arrange, then we use the terminology 3P2. Permute. Permute means select and arrange. The permute word here means select and arrange. And combination means only select. Combination means only select, and permutation means select and arrange. So what are the expansions of this? 3C2 is expanded as 3 factorial upon 3 minus 2 factorial into 2 factorial. 3 factorial is 3 into 2 into 1 upon 1 into 2 into 1. 2 factorial is 2 into 1. So that gets us 3. And that is why there are 3 ways of selecting 2 people out of 3 people, because combination means selecting. Combination means selecting. So in general form, NCR, selecting n articles out of r articles out of n articles will be n factorial upon n minus r factorial into r factorial. But when you have to permute, permute means select and arrange, you are going to do 3P2, whose expansion is 3 factorial upon 3 minus 2 factorial. So 3 factorial means 3 into 2 into 1. 3 minus 2 means 1 factorial, which is 1. So the answer is 6. So there are 6 ways of select and arrange. There are these 6 ways. The general form is NPR. Permute r articles out of total n articles is n factorial upon n minus r factorial. So there are these 2 general forms of NPR and NCR. Again, let me revise what NCR is and NPR is. If you just want to select the articles, r articles out of total n articles, if you just want to select like we did in here, out of 3, you had to just select 2. So in that case, we use this formula NCR. But if along with selection, you have to arrange as well, then we use this formula, which is called NPR. Out of n, we are arranging r. That means selecting 2 and then arranging this. Out of 3 people, we are selecting 2 and then we are arranging in different cabins. So select and arrange. That is what permutation is. And then we are going to use this formula. So friends, is it necessary all the time to have separate formulas for selection and selection arrangement? No, because this name itself says selection and arrangement. So that means you are selecting something and then arranging it. So if you know, for selection, there are 3C2 ways. So with 3C2 ways, you select 2 people. Like if you select A and B, 2 people out of 3. If you have to arrange those 2 people, then you multiply it with 2 factorial. So 3C2 is 3. 3 into 2 factorial means 6. So there will be 6 people to arrange. Basically, you are selecting A and B, and there are 2 cabin 1 and 2. So how many ways you can make sit these 2 people in these 2 cabins? There will be 2 factorial ways. So first you select with 3C2 ways, then you arrange those with 2 factorials. So as far as the banking exams are concerned, this permutation isn't even the case. This combination formula used for one particular type of the question, that is the ball picking from the boxes that we use in probability. Or in some cases, the cards, the 52 cards that we play, out of which you are picking some cards, then only we use this form. So that is why let's not go too much into the depth of NCR, NPR. Let's not get even confused about this. We'll just stay with our basic case of fundamental principle of counting. So as far as these exams are concerned, PNC question is what? Fundamental principle of counting question that we have seen so far. And in probability, there will be application of PNC, and that only of the combination part. That means this part. Okay, let's see one question. There are 4 color stripes, yellow, blue, green, red. How many tricolored flags can be? So first of all, we have 4 colors, yellow, blue, green, and red. How many tricolored flags can be? Of course, provided that horizontal we are putting, because if you are putting vertical, that will be different than we are putting horizontal. So considering we are putting horizontal stripes. So first of all, out of 4, we have to select 3 because we have to form only tricolored flag. So out of 4, if you have to select 3, there will be total 4C3 ways to do that. So out of the 4, if you are selecting 3, there will be 4C3 ways. Say you select yellow, blue, and red. So I selected yellow, blue, and red. Now these 3 colors I have to arrange in these 3 places. So how many ways you can arrange 3 colors in 3 places? It's like making 3 people sit on 3 chairs. So there are total 3 factorial ways. So with 4C3, you select 3 colors, and with 3 factorial, you arrange those, because yellow here, blue here, red here will be different than yellow, red, blue. This flag will be different. This flag will. So if you want how many different flags can be made, that means arrangement also matters. So along with selection, you have to do arrangement as well. So 4C3 is 4. 3 factorial is 6. 4 into 6, that is 24. Total 24 flags can be. But if you do it by fundamental principle of counting, it is again very, very easy, because you know you want tricolor. That means there are total 3 places like this. On the first place, how many choices you have? Either yellow, blue, green, or red. You have 4 choices. If you put, say, red here, can you put red here again? No. That means you have only 3 choices here. If you put, say, blue here, you cannot put red and blue here. That means you have only 2 choices. So we have 4 against 3 against 2. 4 into 3 into 2. Total 24 choices. And hence total 24 tricolored flags can be. That means fundamental principle counting, if you understand very well, you don't have to go into C and P, permutation and combination, for at least for the banking type of exams, because they are never going to ask you those questions where PNC actually will be used. Okay, still we'll see some questions, but I'm telling you as a what you should focus, because most of the students, they find these 2 topics very difficult, because they think everything about the factorial and PNC. But there is a lot more than factorials and PNC. In fact, there is only this much. If you understand fundamental principle counting, if you understand per place number of cases, then it becomes really easy to solve these questions. Let's see some more. There are 4 boys, 3 girls, and a committee has to be formed of 2 boys and 1 girl. So we have 4 boys and 3 girls. Out of the 4 boys, we have to select 2 boys, and out of the 3 girls, we have to select 1 girl. So how many ways you can select 2 out of 4? So you know, selection is combination. That means out of 4, if you have to select 2, you write 4C2. And out of 3, if you have to select 1, you write 3C1. So 4C2 into 3C1. 4C2 is 4 into 3, 12 upon 2, that is 6. And 3C1 is 3. So there will be total 18 cases. This is how you are going to do these questions. Out of 4, if you have to select 2, 4C2. Out of 3, if you have to select 1, 3C1. And you do the product, because you have to select boys also and girls also. Let's see one more. Now, how many different ways can the letters of the word assassination be arranged? So first of all, we have seen one question like folder. But in folder, what happened was all the letters were different. So you could directly say there are 6 factorial ways, because there are total 6 letters. But if there is a repetition, so if repetition is there, for example, the word is dad. So you can't just say dad, we have total 3 factorial, that means 6 words. No, 6 won't be the correct answer, because when you arrange those, like we did in case of folder, we arrange the letters. If you arrange those, if this D goes here and this D goes here, that doesn't make a different word. It still will be dad. So arrangement is not the way here. What you have to do is, you have to consider the repetitions as well. So let's not go into technicality again. Let's just directly go for the solution. So if there is a repetition, what you have to do is you have to see how many A's are there. There are 3 A's. Then there are 3s. In fact, there are 4 in actual spelling, but here in there are 3, so we'll write 1, 2, 3. Then there is 2i. Then there is 2n. And then T and O. So there are total 12 letters like this. So if there are total 12 letters, first you'll write 12 factorial like this. But when you do 12 factorial, you are unnecessarily arranging these 3 within themselves as well. Because this A goes here, or they interchanged with each other. This A goes here, or this A goes here, or this A goes here, and this A goes here. So arrangement of these 3 A's within themselves, it is not necessary because that will make the same word. So we have to derange it now. So in this 12 factorial, you are unnecessarily arrange those 3 A's. So we have to derange it. In this 12 factorial, there is this forcefully 3 factorial is already involved, which arranges these 3 within themselves. So now we have to take it out. Take it out means you have to divide it by 3 factorial. So if you understood it, really good. If you don't, just do it as a method. So because there are 3 A's which are repeated, divide it by 3 factorial. There are 3 S's, so divide again by 3 factorial. There are 2 I's, so divide it by 2 factorial, and there are 2 N's, so divide it by 2 factorial again. And this is going to be the answer. So 12 factorial upon 3 factorial, 3 factorial, 2 factorial, 2 factorial will be the answer. Now, if you solve this, it will be really good. But in exam, the options will be directly, because calculation is not easy. But even if you have to solve, or if you have to pick your answers from the option, at least you can think that my answer has to be multiple of 3. 7. Because 12 factorial will have 7 into it, 3 into it. 12 factorial is what? 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And we are dividing it by 3 factorial means 6. 3 factorial means 6. 2 factorial means 2. 2 factorial means 2. This 6 goes with this 6. This 6 and this 2 goes with this 12 like this. And this 2 can go with this 2. So in the numerator, there is a 5. So our answer has to be multiple of 5. So this cannot be the answer. This cannot be the answer. This cannot be the answer. In fact, we have 2 5s. So our answer has to be multiple of, in fact, 100. So if you solve this, this should come. Our answer has to be multiple of 9 as well. 9 means sum of digits. 3 plus 3 plus 6 plus 3, 9. 4 plus 2 plus 3, 9. Our answer should be multiple of 11 as well. 4 plus 2, 6 plus 3, 9. 9 minus 9, 0. So this is how you can check your answers. You don't have to solve all the time. This will be the answer. How many ways can the letters of the word coaching be arranged so that the consonants remain together? So coaching has C, C, H, and G. These many consonants, and vowels are O, A, I. These are the vowels. Now, if you want these consonants to be remain together, all you have to do is you have to tie them with rope. You have to tie them with a rope. So how many units we'll have? We'll have 1, 2, 3, 4 units. Because these, all the consonants, they have to remain together. There is no condition on the vowels. Vowels can go anywhere. That means vowel you can treat as a separate unit, but the consonant you have to treat as a same unit, single unit, because they have to stay together. So these 4 units, 1, 2, 3, 4, they can be arranged with 4 factorial ways. There are 4 different units. They can be arranged in 4 factorial ways. But within the row, these C, C, H, and G can also be arranged. So that means how many ways or how many different words you can make out of C, C, H, and G. So it is exactly like that assassination question. So what you do is 5 factorial, because there are 1, 2, 3, 4, 5, but you have to divide it with 2 factorial because C is coming twice. So for all such question where some units they are together, we have to tie them with a rope virtually. We have to treat them as a single unit, and that as a single unit, and others as a separate units. The total units are 4. So 4 factorial ways you can arrange these 4. But within the row, these 5 can be arranged with 5 factorial upon 2 factorial ways. So that is what the answer is going to be. So if you again see The answer has to be multiple of 3. This is not multiple of 3. This is also not multiple of 3. Answer again has to be multiple of it. It is not multiple of 7. This number is multiple of 7. No, this is not. This number is multiple of 29 as well. Right? If you divide it by 2, it is 2 times. And 18 means 9 times. But our numerator has no 29 into it. That means this again cannot be the answer. So either this should be the answer or this should be the answer. You can just solve it. It's not that difficult. 4 factorial is 24. 5 factorial is 120 upon 2. This is 12. 12 into 120 is 1440 will be the answer. Easy. How many different ways can the letters of the word drastic be arranged such that vowels always come together? So this time T, R, S, T, C. They are the consonants. A and I, they are the vowels. This time they want to be together. There are now 1, 2, 3, 4, 5 and 6 units. So 6 factorial. And within the row, they can be arranged in 2 factorial ways. 6 factorial into 2 factorial. That is 720 into 2. 1440 will be the answer. Let's see one more. How many different words can be formed with the letters such that the words begin with L and ends with T? That is 8 letter words. So 1, 2, 3, 4, 5, 6, 7, 8. It has to start with L. That means L is fixed here. You cannot change that. And T is fixed here. You cannot change that. So now we have remaining M, A, I, M, I, A. These 6 letter we have to arrange in these 6 places. So it is again the assassination type of question. These 6 we have to arrange here. So 6 factorial upon 2 m's, so 2 factorial, 2 a's, so 2 factorial, 2 i's, so 2 factorial. 6 factorial is 720 upon 2 into 2 into 2 is 8. This is 90. The answer here is going to be 90. How many ways the apple be arranged so that vowel don't change their respective positions? That means A and E have to be there. So we have to just arrange PPL. So how many different words can be formed out of PPL? You know, 3 factorial upon 2 factorial, because there are 2 P's. So you have to divide it by 2 factorial. That is 3. So the answer will be 3. How many 4-digit numbers can be formed from the 2, 3, 5, 7, which are divisible by 5 and none of the digit is repeated? So if divided by 5 you want, divisible by 5, that means the last digit has to be 5. So 5 is fixed here. You don't have any ways for that. 5 is fixed here. So there is only one choice here. You have to put the 5 here. Now against that, the remaining 3, 2, 3 and 7, they can be arranged in these 3 places anyways. Because if you put 5 here, number is automatically divided by 5. That means 3 factorial ways. 3 letters, 3 digits can be arranged in these 3 places with 3 factorial ways. That is 6 ways. So total 6 numbers will be formed. In how many ways 101 different beads can be arranged into a necklace? So we just saw in a circular arrangement, if there are n articles, there are n minus 1 factorial number of ways to arrange those in a circular arrangement. But the problem with necklace and circular arrangement is, if I say there are 3 people, A, B, C, they are to be seated in a circle. So circular arrangement wise, if A sits here, B sits here and C sits here, against whose A sits here, C sits here and B sits here, they are the different ways. If they are the people and they are sitting on a chair, that will be different, because in this case, C is to the left of A and B is to the right of A. Here, B is to the left of A and C is to the right of A. So they are different ways as if people are sitting on a circular table. But if you see this as a necklace or a pearl, So these two arrangements will also be equal, because if I see, if this is a necklace I'm holding, for me, A, C, and B. For me, A's right side is C and his left side is C. This is camera and all. So my right, left with camera inverting it can be a little confusing for you. But you just have to understand this. If this is a necklace and you flip it, if you flip it, it will appear like this. The B goes here and C goes here. That means it is the same arrangement necklace wise. If it is a necklace, it is the same arrangement. If there are people sitting on a chair, that will be different arrangement. But if it is a necklace, it is again the same arrangement. So that means circular arrangement wise, if there are n minus 1 factorial number of ways, necklace arrangement wise, there will be n minus 1 factorial upon 2 number of ways, because every two such combinations, different combinations, they can be converted as single one if that is a necklace. 2 will form only one arrangement, because this and this, they two are the same in case of necklace arrangement. So let's once again revise. If there are n objects or n different articles, if you want to arrange them linearly, then there will be n factorial ways. If you want to make circular arrangement, then there will be n minus 1 factorial number of ways. But if you want to make a garland or necklace, this we call as the garland arrangement, then there will be n minus 1 factorial upon 2. So if you understand it, very good. But as I've been keep telling you, that it is not important to understand this topic in depth. You can just see these typical conditions and remember the formulas as. So garland arrangement wise, there will be n minus 1 factorial upon 2 ways. And if there are total 101, so you can just say 101 minus 1 factorial upon 2. That is 100 factorial upon 2. 100 factorial, you can say 100 into 99 factorial upon 2. Means 50 into 99 factorial. 50 into 99 factorial will be the answer. Let's see one more. In a conference of World Bank, there are 15 delegates. If each delegate shake hand with every other delegate, find the total number of handshakes in the conference. So if there are 15, 1, 2, 3, 4, 15 members, if you want to count the number of shake hands, so you know, any two are going to shake hand with each other. So the number of ways which you can select two people out of this 15 people, those many shake hands will be there. So out of 15, if you select this and this, that will give us one shake hand. If you select this and this, that will give you another shake hand. So number of ways with you can select 2 out of 15. Those many shake hands will be there. So there will be 15C2 number of shake hands. 15C2 means 15 into 14 upon 2. This is the short trick to do that. You can expand it and you will see. This is the short trick. So answer is going to be 105. So if you see this type of question again, you can just remember it as it is. If there are n people, there will be n into n minus 1 upon 2 number of shake hands. N into n minus 1 upon 2 number of shake hands. This is the typical question. Four boys and 3 girls are to be seated for a dinner such that no 2 girls sit together and no 2 boys sit together. Find the number of ways in which this can be done. 4 boys are there and 3 girls are there. Such that no 2 girls sit together and no 2 boys sit together. That means because there are 4 boys, so 1 boy should sit here, then girl, then boy, then girl, then boy, then girl, then boy. Because there are 4 boys, boys have to be at the extremes. Boys have to be at the extremes. So these 4 can be arranged with 4 factorial ways, because boys have to have these positions and girls have to have these positions. So these 3 can be arranged with 3 factorial ways. Boys can be arranged with 4 factorial ways in their own positions, and girls can be arranged in 3 factorial ways in their own positions. So 4 factorial 24 into 6, 144 will be the answer. 144 to the answer. Let's see this as the last question. Everybody in a room shakes hand with everybody else. The total number of shake hands is 5. The total number of persons in the room is. So we just saw the formula. If n people are there, there are n into n minus 1 upon 2 number of shake hands, which is given as 55. So n into n minus 1 is given as 55 into 2, that is 110. So you are just looking for two numbers who differ by 1 and whose product is 110. So easily the numbers are 11 and 10. 11 into 10 is 110. That means the value of n is 11. So the number of people in the room is 11. I hope you got this. So as I told you earlier, this topic is not about the understanding PNC variable. It is just about considering one single part of it. That is first fundamental principle of counting. Of course, in very rare exams, they will ask the question based on that. But the application of it in the probability is, if you have to select 2 articles out of 5 articles, for example, you write it as 5C2 and you expand it as 5 factorial upon 5 minus 2 factorial into 2 factorial. This part is essential for probability, and that is why even if you understood this much along with the typical questions, that should be sufficient. Okay, so let us stop it here. Bye bye, have a good day.